Hello everyone and welcome. In this video we are talking about why Mazda doesn't use CVTs. And I'm not here to bash on CVTs. I think from an engineering standpoint, there are really a lot of good reasons why a company may choose to use a CVT, but Mazda does not. And I do think that part of it is like that Mazda just creates cars that are made for car journalists and not for the mainstream public, because the Mazda tends to have a bit more feel in their cars. They're a bit more exciting to drive, even though they're very mainstream, crossover. I'm sitting here in a Mazda CX-5. It's, nothing all that thrilling, but compared to the vehicles in its segment, it's a bit more enjoyable to drive. But is that necessary for the segment that they're selling in? And I think if you start to look at the Toyota RAV4 hybrid, that has a CVT. If you look at the, Subaru Forester, that's got a CVT, Nissan Rogue, Honda CR-V, and many of these cars outsell this CX-5. So clearly people within the segment don't hate CVTs as much as they're pretending to, because they're still buying the cars like crazy. And so Mazda has this alternative option, which I think is very cool. And I don't necessarily think it's better or worse. I think it's a different strategy, and that's really what I want to explain in this video is why did Mazda choose this strategy versus going the CVT route? And so we're going to kind of talk about from an engine standpoint what Mazda has done differently to pair with an automatic transmission, and then also from a transmission standpoint, what have they done with their automatic transmission to kind of differentiate from the CVT, and what advantages does it have? So when thinking about transmissions, what are the things that are important? Well, you want shift quality, so it needs to be smooth. You want it to be quick. You want to be able to accelerate from a stop without any rough, jarring motion. You want to be able to accelerate uphill from a stop and not have any roughness to it. Obviously, efficiency is very important, and so, making sure that transmission doesn't soak up too much of your power or your fuel economy. And also having a direct feel is important. So, when you have your foot down and you're giving it an amount of throttle, you don't want this spongy feel in the throttle pedal. You want it to do exactly what you're asking of it. So you want a direct feel across the transmission from the engine to the wheels. So if you start looking at the different transmission styles out there, you'll realize, each of them have different characteristics that they excel at. So for example, a CVT transmission, it can put the engine in a very efficient region, an efficient RPM region, and so it can cause, it can create efficiency there. It's not necessarily that the CVT itself is all that efficient. If you start to get on the low end or the high end of its speed range, then it starts to taper off in efficiency. But they're also very good from a start. They've got torque converters, so going uphill, starting from a dead stop, they're very good at that. But they don't have that direct feel, and that's kind of a major complaint of CVTs out there, is you don't have that direct throttle pedal connection to your wheels. There's kind of a sponginess to it. Versus like a dual clutch transmission, you have a very direct feel because you have a clutch engaging rather than a torque converter. There's no slip in the torque converter, and there's no CVT belt that's changing pulleys. So you have a very direct feel with the dual clutch transmission. But from a start, they're a bit rough because you're using clutch packs to start off rather than that fluid coupling, and that fluid coupling is much smoother and accelerating. So if you're going uphill with a dual clutch transmission at low speeds, you can kind of have some jerkiness to it. If you are starting from a dead stop, it's kind of a little rough. And then if you get to automatic transmissions, well, they can be efficient if you lock up that torque converter, and they can give you that direct feel if you lock up the torque converter, but they do still have the efficiency losses of the torque converter, and they still do have that kind of spongy feel depending on if it's locked or not. The shift quality is also kind of all over the place with automatic transmissions. So some of them are very good, some of them are quite bad, and it's quite a rough, jarring experience each time it shifts gears. And so, why has Mazda chosen to go with this traditional automatic with a torque converter style approach versus the other options out there? And they claim that they're able to combine, the benefits of all of the different transmission styles. And so what have they done differently? Well, part of it is in their torque converter. So Mazda's torque converter, it's actually quite a bit smaller as far as the impeller and the turbine, but they've increased the size of the lockup clutch, and they're using a multi-plate lockup clutch rather than a single plate. And they've also increased the size of the vibration damper. And so by doing doing this, they're able to greatly expand the region at which the torque converter is locked up. And you want to do that for direct feel, so it feels good to the driver, and you also want to do that for efficiency, so you don't have those efficiency losses through the torque converter. So they've achieved this by decreasing the size of, that fluid coupling, but increasing the size of the clutch that's required to do it. So very clever standpoint there, and they claim they're getting about 4 to 7% better fuel efficiency in their transmissions than the traditional style where you have that torque converter slipping quite a bit more. So part of increasing the size of that clutch and the damper is that you don't have the vibrations associated with locking up the clutch. And that is a problem with many automatic transmissions. If you lock up the clutch too soon or in regions where you shouldn't, then you get that vibration through the entire drivetrain, and the driver feels that, so it can be unsettling. So from a transmission standpoint, Mazda's strategy is to lock up that torque converter as soon as you can, have it locked as often as you can so you get the direct feel and the efficiency benefits of an automatic. And then from an engine standpoint, they kind of tackle some other problems. So it's really interesting to think about Mazda's engine strategy here. So of course, they want to run regular octane gas because they don't want people to be spending all that much money if they don't want to. In this segment, regular octane gas is pretty normal. So they want 87 octane gas to be available, but at the same time, they want you to have tons of torque. So this engine, 2.5 liter turbocharged engine, 310 pound-feet of torque. And so why do they want you to have so much torque? Well, part of it is they don't want you to feel like you always have to shift gears. So, an automatic transmission, if it's constantly searching for the right gear, then it's just wasting time and it feels delayed to the driver. If you have an engine that has a lot of torque, you don't have to shift as frequently. You can remain in gear and just use that torque in order to accelerate you. Now, in order to make that possible, you really need the torque curve to be as wide as possible, so depending on whatever gear you're in, you can just maintain that torque. And so the way Mazda does this with their turbocharged engine is that they have restrictors within the exhaust, so at low RPM, it creates a restriction that increases the airflow, the speed of the airflow through that turbocharger and spools it up for low RPM, and then that flap opens and allows for more flow at higher RPM, so you can keep that turbocharger spooled up once you have more exhaust gas flowing through it. But now if we go back to thinking about CVTs, CVTs can be designed so that they keep your engine within its most efficient region. So from an engine design standpoint, you can create an engine that, let's say it's only efficient from 2,000 to 3,000 RPM, but if you can use the CVT to keep that engine within that region for most of the time that you're driving, then you don't have to really worry about the efficiency outside of that region. Versus the other approach, which is what Mazda is doing, is saying, look, we don't necessarily have to have this extremely high efficiency peak. Let's just make the engine efficient regardless of what RPM you're at. And so that's what they're trying to do. Broaden it out so you don't have to rely on something like a CVT. You can have a wider RPM region that you use, and in doing so, you get improved fuel economy without some of those drawbacks that a CVT has. So how does Mazda do this with so much torque, with 310 pound-feet of torque? Well, one of the clever tricks that they use is cooled exhaust gas recirculation. So after the exhaust passes out of the engine, you take some of it back, you cool the temperature down, and then you put it back into the engine. So on the surface, that may sound silly. You're thinking, well, why are you going to put gas that you can't even use back in the combustion chamber? Surely that's taking up space that you could have air and fuel making more power. But part of what it does is it reduces your combustion temperatures. And by reducing the temperature of combustion, you reduce your likelihood of having knock. And that's kind of the key to all of it. You get an efficient engine when you have a lot of timing advance and, leaner air fuel ratios. And so what Mazda is able to do by cooling that exhaust gas recirculation when you're going, at a high load, putting your foot down, is they're able to operate closer to stoichiometric conditions because the exhaust gas temperatures are lower, the likelihood of knock is lower, the combustion temperatures are lower, and so they're able to run a leaner air fuel mixture. Whereas most companies in those same high load regions, they're going to be enriching that fuel quite a bit, so your fuel economy is going to go out the window. So that's often why you notice in small turbocharged cars why your fuel economy sucks, is because if you actually put your foot down, they have to enrich the fuel in order to prevent knock. So you have these really rich air fuel mixtures, and as a result, your fuel economy sucks. And you're thinking, well, why did I get this tiny little engine? It was claiming that I would get lots of power and great efficiency, when really it's just doing one or the other. It's not going to do both at the same time. So Mazda's strategy is kind of a broader approach. Don't find a narrow specific region to keep the engine that's really efficient. Allow, for being in whatever gear you want to be in. Don't require shifting as often because shifting, when a transmission is searching, if you drive like a 10-speed transmission and it's constantly searching for the right gear, it gets very annoying to the driver. So Mazda is saying, let's eliminate the need to shift as frequently. Let's have a wide efficiency curve for our engine. Let's lock up the torque converter so we get that direct feel. And all of this kind of accumulates to, it doesn't make all that much sense for Mazda to put a CVT in their car. Their strategy works. Is it going to provide the absolute best fuel economy? Often Mazdas do have, towards the upper end of fuel economy. So it's not to say that it's better or worse than using a CVT, but there are certainly advantages to the strategy that they choose. And I think it is very cool that they're doing something different than all those other mainstream crossovers out there. And to be honest, I've been spending a lot of time the past few days in different crossovers and SUVs, and I've been going down the same road multiple times. And actually, this is one of the, significantly more enjoyable vehicles to drive on this because it's responsive. You do get the direct feel. You do get a lot of torque. It's actually surprising how quick this CX-5 is. 310 pound-feet of torque. You actually genuinely do get to feel it. Mazda puts a little bit of focus in removing weight from cars, so it's not super heavy. You actually do get to feel the torque. So driving this thing is actually enjoyable. It's still a crossover, and if you want to have fun, you should get a car. But from a driving perspective, it's genuinely good. Is that a good strategy? I don't know, because, for example, I put my mom, when she was test driving different cars, I put her in a CX-5 and just said, just see what you think, because I think it's a fun crossover, and that's kind of the segment she was shopping in. Put my mom in it, and she was like, you know what, this is not for me. It's too stiff. The visibility, Mazda sacrifices visibility sometimes for styling elements, and so, it's not for everyone, and I'm not necessarily sure that in the segment that they operate in, it makes all that much sense. I'm happy it exists. I think it's one of the cooler ones in the segment. Is it the best strategy? I don't know, but it's clever nonetheless, and I enjoy the thinking behind, why do they choose to use a planetary automatic rather than going with the CVT like what seems like everyone else is doing. So thank you all so much for watching. If you do have any questions or comments, of course, feel free to leave those below.